Interior, I know I've been harping on its trapezoid, isosceles trapezoid, and parallelogram properties, but also remember we did something day one. Day one, which was, let me just throw one of these figures up there. All right, I have this figure here. How many degrees are in the interior angles? How many degrees are in the exterior? All right, so please don't forget about day one, which was the sum of the interiors. I gave you guys a formula, which was 180 times number of sides n minus 2. So I take the number of sides, plug it in, subtract 2, and multiply by 180. The sum of the exteriors, I don't have a formula for you because it's always equal to 360, the sum of the exteriors. And finally, if you're told a polygon is regular, which probably will be tomorrow, regular polygon, that means all interior angles congruent. Keep going. All the exteriors are equal. And all the sides are equal or congruent. So I know we're doing these 3 figures here, but we also did a day one with all this stuff here. All right, you guys could see number 3. We've been doing it every day. All right, you guys got 24 hours here to know all your parallelogram and trapezoid, isosceles trapezoid properties. I'm not going to harp on the proofs. There's one on there. That's it. There's just one. And I'm going to tell you what it is. It's given a parallelogram, prove triangles congruent. So you will need, obviously, your parallelogram properties for that one. All right. I'm not going to, I didn't think it was right to harp on the proofs. I want to make sure you know your properties and day one. And finally, I just want to remind you mid-segment of a trapezoid, because that'll be tested there. So let me just get a trapezoid out. Connect these 2 sides. First thing, how do you know it's a mid-segment? Because chances are I may not say in the directions tomorrow that LK is a mid-segment. So how do you know it's a mid-segment of a trapezoid? It connects think about the name, mid-segment. It connects the midpoints of the non-parallel sides. So hey, I may not say LK is a mid-segment, but you may see these markings tomorrow. That tells you L is a midpoint, K is a midpoint, and if I connect them, this bad boy is a mid-segment. All right, so now we identified it's a mid-segment. What do you know? How long is it? How do you find the length of every mid-segment? Yeah.
Isn't it the longest side minus the shortest side?
What do you mean longest and shortest? If you're talking about these two, they got names. The parallel sides of a trapezoid bases, but I don't subtract them. Add them. I take 1/2 the sum of the bases. Okay, I take 1/2 the sum of the bases. That's how you find the length. All right. Any questions on what's going to be on there? I obviously know it's going to be a lot of properties. All right, here's what I'm going to do. I'm going to I don't have anything in mind. I'm just going to randomly pick a couple problems from your review. And keep your Chromebooks open, though. Keep your Chromebooks open. I'm going to pick a couple random questions from the review, and we're going to get after it and see how we can do. See what we can do. All right, here we go. Let's start with number 8 from the review. Let's start with number 8. See what we got. Nice little multiple choice question, testing your properties of a parallelogram. So go ahead, read through number 8. Which one is not? We're looking for the false one here. Not always true about a parallelogram. So this is just straight up knowing your properties. And remember, nothing will be on the board tomorrow. We're on number 8 in the review. All right, shouldn't take that long, right? If we know our properties. Are the diagonals congruent in a parallelogram? Diagonals congruent in a parallelogram. I'm getting nervous because some of you are shaking your head yes, and that's not a property. Diagonals congruent is not a property in a parallel. It's a property in an isosceles trapezoid, but not a parallelogram. Get them straight. Get them straight. Okay, all of the rest are properties of a parallelogram. Okay, diagonals are congruent in isosceles trapezoid, but not a parallelogram. All right, let's keep trucking. 9. There you go. All right, let's start here. Testing your properties again. If I have consecutive angles of a parallelogram, what's the property? They are supplementary. So I know 2 angles here are going to add to 180 because they're consecutive in a parallelogram. Number 1, that's knowing my properties. What have we been doing with numbers in a ratio this year? So I can put them in an equation. I can't put just 5 and 4 in there. Attach x's with them. So my one angle is going to be called 5x. The consecutive angle is going to be called 4x. And again, I know it adds to 180 because it's a property. Consecutive angles are supplementary. So we keep moving along here. I got 9x equals 180. Divide both sides by 9. X equals 20. And yes, I put that as choice 1 to suck you in. Circle me, circle me. But you're not finding the answer. We're looking for the obtuse angle, which means the one that's bigger than, what's obtuse? The one that's bigger than 90, correct. So plug 20 in for 5x and 4x. 5 times 20, that gives me 100 for that angle. 4 times 20 gives me 80. That worked out, huh? They add to 180. And of the two, the obtuse angle is 100. Okay. While we're here, because I don't want to freak you out, you can cross off 10A and 10B. There won't be any factoring on yours. That was from my other geometry class. All right, I give you guys the same review, but there's no factoring on your test tomorrow. I would have warned you if there is. All right, let's see, where else are we going here? Let's go to 15. Why not? Let's go to 15. Yeah, there we go. Little trapezoid here and a mid-segment. All right, we just went over our facts. Let's find x first. Let's find x. X plus 2 is your mid-segment. And remind me again, what is the mid-segment equal to here? Length of a mid-segment. Let's go right there. Zoe, length of a mid-segment is equal to? Let me go back to the review that we just went over about a couple minutes ago. Here's what I went over with length of a mid-segment. So apply it to your problem. Okay, what are the bases in this problem?
9.
All right, so finish the equation. X plus 2 is equal to what?
9 plus 3. And that's 6 divided by 2.
So 9 plus 3, what do you want me to do with that?
Divide them by 1.
All right, here we go. 1/2 of 9 plus 3. Everyone's good. Sum of the bases, cut in half. Keep going. 1/2 of 12. X plus 2 is equal to 6, and then we go from there. Everyone good with that? How we work with the mid-segment. Probably going to be a little tougher tomorrow to solve, but. All right, now we got to go Y now. We got to go Y. We've been talking about this property since day 1. What is that relationship there? It's not isosceles, remember. It's just a trapezoid. So what's that relationship between 3y minus 2 and the 122? We've talked about this since the day we talked about trapezoids. Remember Alex, what do I know about those two? 3y minus 2 and 122. And here's a little reminder. Remember, since it's a trapezoid, those are parallel, so those are a special type of angles. Same side interior, so that makes them supplementary. 3y minus 2 plus 122 equal to $1.80. And then y equals 20. Make a note on number 16, please, because 16 you won't be able to find y unless I tell you it's an isosceles trapezoid. Okay, so just make a note for 16 that trapezoid is isosceles. You can find x, but you won't be able to find y unless I tell you it's isosceles. I did want to do a proof with you. Oh boy. Which one should I do here, 11 or 12? Let's do 12 together. And then this will be it. I'll let you go on your own afterwards. All right, I picked this one just because it's similar to what you'll see tomorrow. Tomorrow, you'll be given a parallelogram, prove something's congruent. So I have, let's see, 3 congruent to 4. And I have MW congruent to SN. IM and LN, those two in the proof statement. They're not going to be congruent unless we do what first? Triangles like usual. So everyone there's only one pair, but go ahead and pick them. Pick the 2 triangles that contain IM and LN, and we'll get to it. We'll do IBM along with LON. Get those 2 triangles congruent. We'll do a little CPC. Bless you. Do I have any angles or sides? Or do I need to find all 3? Did I give you any angles or sides, or do I need to find all 3? Or were you given any angles or sides up here? Maddie, did I give you any angles or sides? That's not a pair. That's not a pair of sides I can use, right? What about angle 3 and 4? Can I count those as a pair of angles? Okay, so I can count those as a pair of angles. 1 down, 3 to go. 1 down, 2 to go. I cannot count MW and SN though. Not putting an S next to that. That's not a pair of sides in the triangles. Maybe I'll use it though. I'm sure I will because I gave it to you. All right, let's go back. This is a parallelogram. Mia, anything I could use since it's a parallelogram?
SO congruent to BW.
All right, here we go. SO congruent to BW. Mia's using a parallelogram property. What property is she using? Hayden, what property is she using?
One pair opposite sides.
Okay, yep. Parallelogram implies opposite sides congruent. Now I can't count that as a side in those triangles I'm proving congruent, but I can get there. Where's Mia going with this? She's going to end up doing what here? Subtraction, yep, to get a pair. Good. So we're going to take SO, subtract SN, and then on the bottom we're going to take BW and subtract MW. And substitute in the sides BM and NO. And put a pair of sides there for you guys. All right, so I need one more pair of something. Where's my sides? Okay. A reminder, don't forget about it tomorrow, please. Try not to forget about it. What's BO in this diagram? That's a what of the parallelogram, BO? Diagonal. Anytime you have a diagonal drawn in a parallelogram, it forms what type of angles? Alternate interior. And anybody see a pair? There's a couple pair up here, but a pair specifically in our triangles that are alternate interior, Halo? 1 and 2. Okay, but don't say they're congruent unless you tell me what first? Which lines are parallel. And if you're confused which lines, what's my always piece of advice? Write them both, right? Write them both are parallel if you don't know which one has to be parallel. Write them both. So BW, SO, parallel to BW, and I'll even do it. SB and OW. Write them both. Parallelogram implies opposite sides parallel. Look for a diagonal. Look for a diagonal on your quiz. Now you can say 1 and 2 are congruent. And I'll go back to you guys. What's my reason for 1 and 2 being congruent? Jackson, 1 and 2. What type of angles were they?
Alternate interior.
Okay, so I don't want to write alternate interior though. What did I just show in this step before?
Oh, that like the lines.
So
parallel lines and alternate interior.
There we go. And there's a pair of angles. Do I have enough to say the triangles are congruent? Yep. Now I just need a method. Triangle BIM. Let's see if I go BIM OLN. Method. Or are the triangles congruent there? Juliana? Good job, angle, side, angle, and then you guys can finish it off with CPCTC. So something similar like this one tomorrow. Use your parallelogram properties to get triangles congruent. All right. Chromebooks, get open the review for quiz answer key on your homework section. Okay, you guys are already in Unit 5. Now open up the homework answers for me. Find review for quiz. Find the review for quiz, and there's the answer key. Scroll all the way down, please, on the answer key. Scroll all the way, scroll all the way to the end on the answer key for me. Scroll all the way to the end. Does everyone see I put the textbook answers at the end there? Please try those textbook ones. They're pretty good too. All right, so the textbook answers are there too. All right, go ahead, get going.